We had also solved some of the questions, but today let me tell you there are some more types of numbers. You might have seen real numbers. You know what are real numbers? The real numbers will have both rational and irrational numbers. That you know, right? Real numbers will have rational and irrational numbers. Okay, that's why if you take a real line, this is a real line. This real line contains both real numbers and somewhere here you will have root 2. You know that root 2 is a irrational number, right? Irrational number, and this 2 is a rational number. You can see this real number line will have both rational and irrational number. Okay, now we'll study the very important type of number, that is complex number. Complex numbers. Okay, now if you look at these complex numbers, this is much more bigger. This has much more bigger numbers compared to real numbers. Now a best example for complex number is a plus ib. This is the general format where where a and b are real numbers. Okay, where a and b are real numbers. Now another example you can take as 1 plus i2. 1 plus i2, you cannot exactly compare two complex numbers, but I'll tell you how you can graphically represent them. Now let's imagine that we have got a x-axis and y-axis. This is our x-axis and this is our y-axis. If you consider this as a real line, you will have 1, 2, 3, 4, 5 and on so on. Actually this is going to take values of a here, this a value. And if you consider this part, minus 1, minus 2, minus 3, 1, 2, 3. If you want to represent this part, it will be like 1 comma 2. This point can be represented as 1 plus I2. Right. This is our complex plane. This is our complex plane. You can represent any complex number on this plane. Okay. You will require two x's. Two x's are required to represent complex numbers. Okay. So for representing real numbers, you will require only one line. So real numbers can be represented in 1D, one dimension. But to represent complex numbers, you will require two dimensional. That is, you will require a x-axis and y-axis both. I hope this one is clear. I hope you understood how we represent complex numbers. Complex number format is a plus b, and for representing a we will use one axis, that is x-axis, and for representing b we will use y-axis, and to represent 1 plus 2 you will mark 1 comma 2 point, and that will be our 1 plus I2. This is the complex number, and by now I hope you are able to see that complex numbers are much more broader than real numbers, because I can call all complex numbers are all real numbers are complex numbers. All real numbers are complex numbers. Complex numbers. For example, I can write 2 as 2 is a real number, right? 2 is a real number. 2 can be written as 2 plus I0. So this is a complex number and this is a real number. You can write real numbers as complex numbers. That's why we can say that a real number is part of complex number. part of complex numbers. Okay, I hope this complex number concept is clear. Anybody any doubt in the complex number concept? We will require this whenever we are solving some of the questions. Okay, if you have understood, give a thumbs up. We'll go to the next concept. Okay, good. Now if I ask you whether you have understood, just give a thumbs up. You need not comment and all. Okay, now we'll just try to see, compare all the number types that we have studied. We'll draw a Venn diagram. See which is the smallest set of numbers. Smallest set of numbers means which number set contains the smallest numbers. Can you tell me whether it is natural numbers, whole numbers, integers, real numbers? Which is the smallest set of numbers? Anyone? Okay, I'll just write the first one. Smallest set of numbers is natural numbers. Natural numbers. Then if you include 0, it will become whole number. It will become whole numbers. Then can you tell me what is the next? What can be the next one? Yes, natural numbers. That is correct. What can I write here? Can you guess? See, natural numbers are actually part of whole numbers. In natural number, if you write 0, then it will become whole numbers. And what can I write here? This part. This is going to be integers. Because whole numbers plus negative numbers. Negative numbers. They are going to be integers. Whole numbers plus negative numbers are going to be integers. I hope this one is clear. Yes. Okay. Now we'll try to see integers will come in what? A bigger circle. In this, can you tell me what will come? Anyone? You can have real numbers, right? All integers are real numbers, right? And there is some another set called as, okay, there is one more thing we are missing. This is actually rational numbers. Rational numbers. Integers are rational numbers, all whole numbers are rational numbers, all natural numbers are rational numbers. Because if you take 2, 2 can be written as 2 by 1. So 2 is a rational number, 2 is a natural number, 2 is a whole number, 2 is a integer, and 2 is a rational number also. But if you take 2.1, this is not natural number, not whole number, not integer, but it is a rational number. That's why here what we get is this part is decimal number. Decimal numbers. Okay. Can you tell me what will come in this circle? Guess. This one, this circle. This is rational numbers. I am going to draw one more circle here above all of this. This way. This circle. What is this one? Irrational. Correct. It is going to be what? Irrational. It is irrational number. These are rational numbers. This is irrational number. When you have both rational and irrational numbers, what do you call that one? Yes, we call it as real numbers. We call these as real numbers, and these real numbers are actually part of another number. Can you tell me what is that? This bigger circle. All real numbers, just now I taught all real numbers are complex numbers. But there are some more numbers like 1 plus 2i. This is not a real number. 1 and 2 are real numbers. But 1 plus 2i is not a real number. You can write 1 as 1 plus 0i. You can write 2 as 1 plus 2 plus 0i. Okay. So all real numbers are complex numbers. Complex numbers. You got it? So this is your all number systems. You should understand this very clearly. Yes, complex. That is correct. This diagram is very important. You should understand. Now in exams sometime you will get a question like this. Which of the following is true? Which of the following is true? Following is true. They'll give option A. All real numbers are natural numbers. All real numbers are natural numbers. Second one, all natural numbers are real numbers. Numbers are real numbers. Third one, all complex numbers are real numbers. And the fourth one is all real numbers are complex numbers. All real numbers are complex numbers. Can you tell me which of these are true? Which of the above given statements are true? All real numbers are natural numbers. All natural numbers are real numbers. There are two statements which are true, and there are two statements which are false. They will ask you like this: uh, which of the following statements are false or true? So yes, option 2 and option 4. These are correct statements, because you know that all natural numbers are real numbers. If you look at this diagram, you will understand. We have got natural numbers are here and real numbers are here. You can see this natural number is inside real number. That's why all the natural numbers are real numbers, because the real number is a bigger circle compared to the natural number. Okay, I hope you understood these kind of questions. You should know this. This is very important. Anybody, any doubt? Okay, no doubts. And one more concept, prime numbers. I have already taught this in the first class itself. You need to know what are the prime numbers. I'll just revise once. At least you should know till 100 how many prime numbers are there. Primes are there, because in exam sometime you'll get a question: how many prime numbers are between prime numbers are between 1 to 100. You'll get a question like this, and they will give you options. First one 20, second one 22, third one 25, fourth one 27. So what will be your answer here? What is the answer of that question? How many prime numbers are between 1 and 100? 1 to 100. Anybody? How will you solve this question? It is actually very difficult to find out all the prime numbers between 1 to 100 and then answer this question. It will unnecessarily take lot of time. Okay, it is 27 you say. Already I have taught this, you are not revised. That's why I used to tell it is not 27, actually it is 25. We'll just count once. Already I have told you how you will write the prime numbers: 2, 3, 5, 7. Okay, this is the first set, and the second set is 11, 13, 17 and 19. There is a reason behind why I am writing like this. You can see this part here, all values having 3 as their reminder when you divide by 10. Okay, this is the second set, and if you see third set, this is 23 and 27. Okay, 27 is divisible by 3, so you will not take 27, it is actually 29. Okay, so there are two here. You need to remember these three lines. This is important. Fine. Okay, 31 and 37. Okay, after that you just see they will go on repeating: 41, 43 and 47. 41, 43, 47, and then 53 and 59. You look at these 53 and 59, they are similar. And then next 61 and 67. 61 and 67, these two are similar. 61 and 67. And then next 71, 73 and 79, these both are almost similar except this number and this number. So if you can remember these three parts, these four lines, then I think you will be able to write till 100. Then you see next we have got 83 and 89. See this 53 and 59, 83 and 89, they are again repeated. And then at the end you have got 97. Remember, from 90 to 90, 90 to 100 you have got only one, that is 97. This is the last one, and the first four lines has to be remembered. After that these are going to be repeated. Just identify the pattern. Identify the pattern, then you will be able to remember first 100, because sometime straight away questions of this type will be asked. At that time identifying all the prime numbers is very difficult, and that's why now if you try to count how many are there, we have got 2 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. This is 25, so the answer of this question is 25. That was taught in the first class, how to write prime numbers. You can just refer that once if you are not understood now. Okay, I hope this was clear. Sometimes in the exam you will have a questions like this. Okay, I'll give you a question here, just observe that carefully. Which of the following, which of the following numbers are prime? Numbers are prime. They'll give you like this: first one 165, second one 247, and third one 571. If you look at this kind of question, it looks very difficult, right? You have to identify whether 165 is prime or not, this is prime or not, this is prime or not, and identifying whether a number is prime or not is actually very time consuming. Do you agree with me? It is time consuming, right? I'll tell you a trick how you can solve these questions. There is a rule. There is a rule when you are solving such questions. You have to remember only that rule. If you want to check 165 is a prime number or not, you just need to check whether it is divisible by numbers less than square root of 165. You need to check with the prime numbers, only prime numbers. It's divisible by prime numbers less than 165 or not. Can you tell me what are the prime numbers which are less than root of 165? Anybody, what is root of 165? Prime numbers less than root 165. Can you tell me what is root 169? Root 169. 13. Yes, root 169 is 13. So what are the prime numbers less than 13? I have got 2, 3, 5, 7, and then 11. Right? These are the prime numbers less than 13. You need to check whether this number is divisible by only these few prime numbers. See, before this rule, you are feeling like you have to check with all the numbers, but now I hope this one is very clear that you are going to check with only few numbers, and it is very easy to find out whether a number is divisible by 2 or not, 3 or not, 5 or not. There are some rules. You need to check those rules. Okay. I hope the rule is clear. Any given number, find out what is the prime numbers which are less than the root of that number. As we have done here, I wanted to find whether 165 is prime or not. For that, what you need to do, just find the root of 165. Finding root of 165 is a bit difficult, so you just take a nearby square number. Nearby square number, that's why I considered 169. I know 169 is a square number, so I have considered that, and it is equal to 13. So I have to choose all the prime numbers which are less than 13. Now try to divide 165 by 2. Is it divisible? Is 165 divisible by 2? How will you check it? No, right? 165 is not divisible by 2 because what is the rule to check whether a number is divisible by 2 or not? What does the rule says? If you want to check whether number is divisible by 2, it should have in the units place, you should have a even number. Then we can say that a number is divisible by. I hope you know all these rules. How will you check whether a number is divisible by 3 or not? If the sum of digits is divisible by 3. Divisible by 3. First one is you need to check the unit place. If it unit place is even, then you will be able to say. Now, for example, if you take 144, is it divisible by 2? Basically, we are checking whether it is even or not. 144 is divisible by 2 or not. You will just check the units place. Unit place is 4. Since 4 is even number, we can say that 144 is divisible by 2. You got it? Now to check whether a number is divisible by 3 or not, you will just add 1 plus 4 plus 4. So what is the answer? 9. Is 9 divisible by 3? Is 9 divisible by 3? Yes, that's why 144 will also be divisible by 3. So how will you check whether 165 is divisible by 3 or not? You just add 165. What is the answer? So it is equal to 12. It is equal to 12. That's why 165 is divisible by 3. So you cannot say that it is a prime number. This is not a prime number. You understood? Any doubts in this case? You need to know the rules of identifying whether a number is divisible by something or not. Now, how will you identify a number is divisible by 5 or not? In the units place, if you have 5 or 0, you have to make note of these things. Whenever you are observing a number, you should be able to identify whether it is divisible by some number or not. And if you see 7, how will you identify a number is divisible by 7 or not? Have you studied this part? Do you know how a number is divisible by, how can you identify a number is divisible by 7 or not? Anyone? Okay, we'll just try to, I'll tell you the rule. You will take the units place, you will take the units place and try to multiply that by 2. You will multiply the unit place by 2, and then you are going to subtract from the remaining value. I'll give an example, 203. Now if you want to check whether 203 is divisible by 7 or not, what you will do is you will take the units place. What is unit place here? 3. 3 into 2. So what is 3 into 2? It is going to be 6. Right. Now you are going to subtract this 6 from the remaining value. That is 20 minus 6 is equal to 14. Since 14 is divisible by 7, you can say that 203 is also divisible by 7. Isn't it interesting? You can check any number divisible by 7 using this rule. You have to take the units place, multiply it by 2, and then whatever the value you get, subtract that from the remaining value, and if that value is divisible by 7, and then the whole value that you have got is divisible by 7. This is the trick to check whether a number is divisible by 7 or not. Okay, you need not divide and check the whole number. I hope this much was clear to everyone. We'll try to give some of the questions today. Okay, and you try to solve that. If you there are any doubts in the questions that are given, you can ask in the next class or anytime when I am free. Okay, I hope this was useful. We'll take a leave.